Good evening, everyone. Welcome to this webinar brought to you by Bursa Malaysia and managed by LifeChamp. So today our topic is revisiting Industrial IoT, Industrial 4.0. All right. Yes, David, I'm not nervous. Just that, my
just kidding.
PowerPoint just crashed right before I want to share screen. So I'm going to pull out all my PowerPoint. So apologies for the delay for a bit. So welcome everyone for this session. My name is Shen Chu. I'm the moderator for this session. Now, what is IoT? IoT is the Internet of Things, okay, which is, I think, making a big wave now. So now a lot of electronic devices can talk to each other. And this is an emerging trend that will bring spillover benefit, especially when it is applied in the industrial area. So today, we are going to look into how is the evolution of this industrial IoT and what is the application and what are the businesses, case study or companies in Bursa Malaysia that can benefit from this emerging trend from this industrial Internet of Things. Disclaimer, whatever we want to share on this webinar is only for educational purpose. So in no way that we give any recommendation for you to buy or sell any listed companies should we mention here. So if you decide to make any investment decisions, you're 100% responsible for all your investment risks. All right, so allow me to briefly introduce our speaker today, and he wants to keep the introduction short. So David graduated with a Bachelor of Engineering Electronics majoring in Telecommunication from Multimedia University, Cyberjaya, and he built his career in the telecommunication industry for 10 years before turning to his passion in value investing. Now he is a full-time investor and he provides value investing ideas and advanced portfolio strategies for high net worth individuals. He is often invited to speak at Bursa and also broker seminars, webinars, workshops, and his professional comments and opinions on value investing are often featured in business publications such as Focus Malaysia. So welcome to join us in this webinar, David.
Thank you, Shane. You still read out my entire profile. It's good to be back.
First one sentence and the last paragraph.
Thank you. Please allow me to share my screen, please.
Please go ahead.
Thank you. Good evening, everyone. It's nice to be back. Hope you guys are doing well despite the bloodshed happening out there, not just in stock market. I think in any asset class, even businesses are actually really suffering. Now, I see that on the chat. I think we have about slightly more than 100 packs joining us tonight. Maybe plus another couple more on the YouTube. So I would like to congratulate you guys for being true to the spirit of learning despite what is happening in the market. In fact, in my personal opinion, now is the best time for you to own your skills and sharpen your focus, so that you can gather more information, equip yourself with more data, with more knowledge, so that when the market does return, which we know will happen eventually, you are more than ready. Yeah. So tonight is another topic which I really like. Although I used to be an engineer, this is not an easy topic. Because it deals with computing and networking, and which is not my forte. But anyway, the trend, just like what we talked about a session ago regarding the EV, the rising trend of EV. In fact, Industrial IoT is also another mega trend that we should not miss. All right. So when we say mega trend, it's not just a trend that will be in force for a couple of months or years, right? I mean, we believe that this will be the big trend, the coming big trend, which will last at least 5 to 10 years time. Okay, so this is our second installment of the topic. We talked about IoT, I think, sometime last year, towards the end of last year as well. This is just a follow-up, but we are maybe turning the microscope into a different segment of the industrial IoT. So as usual, I normally split my talk to a few topics. So I'm gonna maybe talk a little bit about how the world has survived the COVID-19 and how IoT played a role, and how IoT will play another role in mitigating the next crisis. Then we will take a look discuss a little bit about what are the emerging IIoT trends, particularly in manufacturing or industries. Then tonight our focus will be on HPC. So no worries if you have if you don't remember what we talked about last year. I will give you guys a very quick a recap on what are the important points from last session. Yeah. Then last but not least, we'll close out with 1 or 2 case studies. But this time it's going to be different because I normally only talk about case studies in Malaysia, in Busan, Malaysia. But this time I'm going to start the case study with a company which is listed over elsewhere. But again, of course, there is a reason for it, which I will show later. So make sure you stay until the end. All right. Now, let's move on. Sorry about that. Okay. Now, just to recap, I'm sure you guys know who this person is. He's none other than, right, the larger-than-life Mr. Nikola Tesla. Now, Mr. Nikola Tesla is known for many, many things. One of the things that, one of the roles that I really respect him for is his visionary of being a futurist. Okay, I think this statement was actually given by him more than 100 years ago. I think back in 1926, right? He did say that, I think in one of the interviews or one of the articles, Mr. Tesla said, where wireless is perfectly applied to the whole Earth will be converted into a huge brain, which in fact is all things being particles of a real and rhythmic whole. We shall be able to communicate with one another instantly, irrespective of distance and blah, yada, yada, yada. All right. So Mr. Tesla was talking about, internet, that he already foresee how internet would change the whole world, right? Communications, right? And little did we know that, when internet came, we all thought that it's just to bridge, interconnectivity between humans. But now we are moving to a whole new era where there is actually internet will help us interface with the cyberspace as well as physical systems, right? So that is the gist, the spirit of what Internet of Things is about. Now, last session, this is one of the slides that I used last session where I talked a little bit about the history from Industry 1.0 all the way to 4.0. Now, I would just like to recap and remind our audience tonight that Industry 4.0 is really about interconnecting all the things which can be connected through the internet. So interconnectivity or accessibility is very important, which by extension, we will have a lot of real-time data. All right, then we can integrate, the interfaces between cyberspace as well as physical systems. And that is really the heart of what Industry 4.0 is about. And to enable or to make this work, right, to make Industrial IoT, Industry 4.0 work, right, these are all the players or all the elements that need to come in place. So some technologies may come sooner, some may come later, some may mature much, much later only, but they are all in the timeline or on the roadmap of this Industry 4.0. That is why just now I said that this trend, this mega trend will last at least for the next 5 to 10 years or even longer before the next wave comes about, right? So tonight we focus on IR 4.0 or what we call IIoT. Just another recap. So there are 2 main groups of what IoT is about. I think most of our listeners will be more familiar with the consumer side of Internet of Things, where this is how we are connected to each other, to the world, to the internet, through our devices, through our smartphones, through our iPads, smart devices, through our things at home, on the roads, and so forth. But there is another side of the of the Internet of Things, which is on the industry side. This is where we have, everything. This is where we have the smart factories, the grids, the machine-to-machine interfaces, the smart city planning, vehicle-to-vehicle communications, telemedicine, manufacturing, so on and so forth. So tonight, just to be clear, our focus is on the the Industrial Internet of Things. And just to clear any ambiguity as well, when we talk about Industrial Revolution 4.0, or in short, Industry 4.0, right? We are actually referring to the Industrial Internet of Things as well. So we, at least for my sessions, where as far as my sessions are concerned, I will use these two terms interchangeably, all right? It means they actually both terms mean the same. All right, so without much further ado, let's move to the second topic of actually how the world survived the pandemic, or are still surviving, and what can we learn from the lessons gained, and to be ready, to be more ready for the next crisis. Okay, as we all know, the COVID-19 pandemic shocked the world. All right. So as an impact, we went through a lot of hardships, including economic suspensions, shutting down of borders. We started from the US and China, and so on and so forth, and social lockdowns, right? And think about it, time really flies, because think about it now, we are more than 2 years past the initial lockdown way back in March, right? So what have you learned from this? I believe in any experience in life, we stand to gain as long as we have a positive mindset. So ask yourself, what have you learned? What have you gained through this hardship? And how are you going to do better moving on? So I think it is no-brainer to say that actually these COVID lockdowns, as well as the impacts as a result of it, right, really changed consumers' behavior in a huge way all around the world, not just our country, not just our nation, not just our region, right, but across the world, right? Consumers as a whole are changing. The way we shop, the way we communicate with each other, the way we work, the way we educate ourselves are all changing. Markets are changing its dynamics as well to reflect all these changes, changes in the way we do things. And also, interestingly, a lot of new R&D themes are popping out, especially towards the area of digitalization of industries, of medicine. Anything can be digitalized these days, and the speed of it is really unprecedented. So tonight, I'm going to focus more on this part where, we'll talk about data integration, networking, and I'm going to touch a little bit about digital twins later. But the central theme is how this consumer behavior, the paradigm shift in consumer behavior is pushing certain technologies forward in a much faster manner. Okay. And one of the things is actually increased IoT adoptions. More and more money, more and more capex, more and more resources are being poured into the adoption of IoT, Internet of Things, in industries after the wake of this pandemic, right? So nowadays, we have a lot more and more, remote monitoring is being installed, all right? Whether it is in this manufacturing, in security, so on and so forth. In fact, also on a social angle, we are so used to being geotagged already. I mean, just because of the little virus, right? We gave out we gave out our right to the governing bodies to actually tag us or to follow us wherever we go. Every time we scan the MySejahtera, and it's not just in Malaysia. In fact, in most of the countries that we know, they do enact similar systems, right? So this will also bring about a new wave of technologies as well as social systems, right? Also, 3D manufacturing is becoming more and more popular. All right. There will be more near field communications. Not sure how many of you just gotten your NFC touch and go card. This is pretty interesting, I guess. Right. But what I'm trying to say is actually there are a lot of focus, all right, being directed towards using IoT to enhance our way of life, and that includes manufacturing as well as other industries as well. Okay. So just a little bit of data. This is a report, quite a recent report by this company called Inmarsat. All right, they released this report called Industrial IoT. So they study what are the the main drivers of IoT adoptions, what will be the budget concerns, so on and so forth, right? So interestingly, what we found out, I just gathered the important points, some of the important points from this report. They found out that among the top 5 drivers of IoT adoption, all right, across global organizations, number 1 on the mind is always about cost. All right, they believe that by adopting IoT, it can help them to manage or even reduce their cost significantly. Right. Of course, other than that, there are other issues at play, including environmental sustainability. This is where we talk a lot about ESG. Better supply chain management insight. This is also part of how they can enhance or increase the efficiency of their businesses. All right, greater automation, as we know, with the pandemic, when we went through this social lockdown, and nobody went to work, but still, people require certain products. People still need to consume. Somebody has to produce, right? So then a lot of business owners, a lot of organizations face the constraint of human resources. That's why a lot of industries are moving, spending money actually to embrace more automation in the businesses or in their production, right? So this is also a major driver of IoT adoption. Better decision making, as you know, with more data, you can actually make better decisions. You can feed those data into a machine that like a machine with artificial intelligence capabilities to generate more insights on how you can enhance. And all of these, all right, except for maybe the second element of which is related to ESG. All the other 4 drivers are somewhat related to driving the top line as well as the bottom line of any business. As you know, most businesses, in fact, all businesses are created to make money, right? To make profits. So I think naturally, IoT adoption can help a lot of these businesses achieve that goal. So another interesting takeaway from this study is that I think they interviewed more than 400 organizations. I can't remember what's the exact number. They asked these organizations what proportion of the organization's IT budget does the management expect to spend, following for the next 3 years after this pandemic, right? Interestingly, close to 10% of the respondents said that they will actually spend a lot of money to do to implement IoT projects, which includes cloud computing, security, big data analytics, robotics, which are related to automation, machine learning, which are related to better decision making, so on and so forth. So the reason why I'm sharing this is to show you that actually there are going to be a lot of money or capital being poured into the implementation of IoT. All right, and IoT has many layers. All right, and this is where investment is all about following the money. All right, so definitely there is going to be a lot of investments into this area. So we should also take some time to really study this so that we don't miss out the big wave. Okay, so if you want to know more about this report, which is quite interesting, I have a link here. All right, you can visit the link later when you're free. Okay, thank you. Now, next, so what are the emerging trends and impacts specifically on manufacturing after all of this? Yeah, so in all my research regarding IoT or industrial IoT, I always refer to this website called IoT Analytics. It is IoT-analytics.com. They are quite good. All right, they have a lot of information, a lot of white papers, articles, as well as paid resources if this is your thing. But for tonight, I'm just pulling out one of the recent articles about what are the 10 IoT technology trends to watch in 2022. Now, of course, I'm not going to go through all 10 of them. I'm just going to highlight a couple for you for the purpose of tonight's session. Now, first and foremost, it's very interesting to see that actually one of the trends that we have to watch in the IoT space is that the platform is moving from the cloud to the edge. Now, a lot of us, last time when we talk about IoT, right, we always think about how the computing power resides on the cloud, right? Because of scalability, because of economies of scale, so on and so forth, right? But in fact, the study has shown that more and more organizations, more and more businesses are actually moving a lot of the computing or a lot of the these networking needs from the cloud towards the edge. Now, don't worry, I'm going to explain what is actually the edge later on with you guys. Then the second trend that I want to highlight is actually a lot of initiatives from surrounding IIoT, the industrial Internet of Things, transforming manufacturing in a positive way. Okay, and that is why we talk about IR 4.0 tonight. Then AI is interestingly increasingly found more popular, being utilized in the thin edge. I'll explain what thin edge is again later on. And then invisible AI adoption is happening right under our noses. In fact, unbeknownst to us, a lot of things that we are doing now, which is when we access the internet, when we access the apps on our phone, the way we do our shopping. Actually, behind there's a lot of AI capabilities that is being used. All right, on the server side to package the best advertisements or the best solutions for us, and this is happening right under our noses. You won't feel it. Okay, so tonight I'm just going to focus on these four major themes or trends of IoT, not just in 2022 but moving forward. Yeah. This is a slide from McKinsey, also from one of their recent reports on IoT 4.0. So again, this is just to show you, how what are the top drivers of IoT adoption from another angle. So from this McKinsey report that they found out that actually a lot of organizations are embracing IoT mainly to improve the accuracy in forecasting. Forecasting on what? Forecasting perhaps on their inventory management, on their supply chain, on their sales, on their workforce management, so on and so forth. And then the second major driver is actually how they can better utilize their labor productivity, right? Because some portions of the manufacturing could use more or less labor, so on and so forth. Then, of course, with all the other cost-related drivers as well. All right, so more or less the same from what I shared about the 5 drivers of IoT adoption earlier. Okay, again, the report is available on the website. Just Google IoT 4.0, McKinsey.com. You should find a lot of reports regarding this. All right, so we talk about what are the main drivers of IoT adoption just now. So what can be done to, how can these improvements be made, especially in the manufacturing line? As we know that, I think I talked about this in the last session as well, just to recap, IoT Industry 4.0 can actually help, especially in the industries or manufacturing sector, through automation, through supply chain optimization, through asset tracking and optimization, and last but not least, predictive maintenance or analytics, which is, I think, one of the most important features or benefits of IoT, right? This is a slide that I got from, a picture I got from maintenance.org. Basically, it shows the DIPF curve, which stands for design, installation, potential failure, and failure. Okay, of course, when you set up a manufacturing plant, to produce whatever goods, perhaps gloves or batteries, for EVs, right? You naturally always have to go through the design process as well as the installation. Now, this is where being precise is very important. You had to get the right design. You had to buy the right equipment. You have to install it the right way, so that when you turn on the key, the machines will work, right? But what happens after the machines are turned on and it works after for some time, right? This is where a lot of maintenance elements can actually be taken over, can be enhanced through the implementation of IoT. Now, what this graph shows is actually, if on the vertical axis, it shows that if, let's say, the design or the installation is done properly, all right, the chances for the system to fail is actually very low. All right, but I mean, that's why it's called resistance to failure. But I mean, naturally, of course, if you chose the wrong machines for your production, or that you install it not in the proper way, sooner or later your machine is gonna break. It's gonna break down, isn't it? The same thing when it goes into production and machines go through wear and tear. This is where a lot of these IoT features can be implemented to help the businessman, to help the producers save costs. Why? Because a lot of things can be anticipated through IoT. So how is it possible? For example, a lot of sensors. I mean, you can see from here a lot of ultrasound sensors, vibration sensors, fluid analytics, motor testing, infrared sensors, so on and so forth, can be implemented throughout the production line, so that these sensors can gather data and be presented to the maintenance personnel or to the management, so that they can be highlighted, they can be alerted in case there is any tendency or any probability for the machine to break down, right? Or not just about machines breaking down or machines efficiency. It can also help them keep track of the inventory of the raw materials, of their operational efficiency, so on and so forth. Now, traditionally, without computers, without IoT, right, the only thing that people can do is really through human intervention. And according to this graph, I mean, and it's also quite logical, when that happens, when the machines break down, something caught fire, some chemicals spill out, oil leakage, so on and so forth. Normally, when that happens, the cost to fix those issues can be quite high. All right, and it will definitely hit your production yield. It will definitely hit your operational efficiency, and which in turn will drive down your revenue, or drive down your profit margins. Or that is why this is where all these predictive analytics can help prevent this, right? And that is why moving to the next slide, talk a little bit more about what is predictive maintenance. All right, predictive maintenance can be broken into 4 levels, or 1, 2, 3, and 4. From level 1 to level 4, it is where level 1 has more is more concentrated on human intervention, where you only fix things when it's broken. There is a saying that you should not touch the system unless it's broken, right? But in manufacturing, it can a lot of headaches can be avoided. A lot of losses can be avoided or minimized if we have certain some sort of predictive alerts that can tell, hey, something is wrong. Of course, there is a better way other than just wait and see. Actually, a lot of manufacturers are implementing this scheduled maintenance. Now, scheduled maintenance is also a no-brainer. Just like when you're driving your car, right? You are supposed to service your car, I think, every 4 months or 6 months, or when your mileage reaches a certain when your car reaches a certain mileage, say 5,000 or 10,000 kilometers, depending on what kind of engine oil you use. The same goes for machines. The same goes for these manufacturing lines. All right, you can have planned maintenance as well. But of course, planned maintenance is, as the name implies, planned. There are a lot of things that may happen, that may occur in between each maintenance periods, which is out of our control. All right, and if there is no predictive capabilities in your production process, this may also hit a dent in your pockets quite substantially. That is why the smarter thing to do is to implement level 3 and level 4, where there's a higher element of proactiveness as well as predictive analytics implemented into the system, right? Now, for example, just again coming back to driving your car, because I think a lot of us are familiar, especially if you're driving new cars. Your cars these days are also equipped with a lot of sensors. Just for example, there will be sensors on your tires. When your tires pressure is going low, the sensors will light up. All right, to remind you, hey, you need to increase the pressure on your tire. Or when the on your fuel or your gasoline is going low already, the indicator will blink for you to prompt you to go to fill in your gas. Now imagine if you do not have that, kind of indicator. All right, you drive your car until there is no more gas, no more fuel. Then the cost of refilling or getting your car back on the road again is much higher, than vice versa, right? So that is the spirit. That is the logic of why predictive and proactive maintenance is very important, and this will definitely help the manufacturing companies save a lot of money. All right, in the long term, as well as increase their the overall equipment effectiveness, or they call OEE. OEE is a very common term in manufacturing lines. So of course, the higher the better. OEE will also tell you how, not only tell you how effective or how efficient the machines are running, it can also help you prolong the lifespan of your machines if all this proper maintenance and proper if all these machines are being taken care of. And that is why IoT is very important, plays a role in the predictive maintenance. Okay, give me a couple of minutes to talk about this thing called digital twin. I find this a very impressive implementation of IoT. I'm not sure if you heard of it. If you're not, if tonight is your first time, right? Please, after this session, please go and Google to read more about what digital twin is about. I personally believe that digital twin is going to be very important. It's going to be the next emerging sub feature or sub trend in the world of IoT, right? So basically, what it means is, as the name implies, digital twin. What they do is they actually have a virtual representation of the physical system. For example, in this case, a factory. Now, a factory has a lot of modules, have a lot of machines, has a lot of computing modules, parts, right? Now, what you can do is you can digitalize the function of each module into a system like this. Of course, this is a very nice visual representation. Of course, in the computer, it doesn't look like this. This is just for the benefit of our human eye, right? So what this digital twin does is the physical system can feed data through the sensors I talk about, right, into this digital twin. All right, and this digital twin can take off all these data, all right, to create a model of how the machines work. Now, through that, of course, by learning, so this is where machine learning comes into play as well. The digital twin can know when certain parts of the manufacturing line need servicing, some certain parts need to be replaced, and so forth. And of course, that is just the maintenance. Of course, there are other elements at play. For example, tweak the optimization of the production line. So some parts of the production can be tweaked, right, to improve your productivity. Some parts can be tweaked, to reduce wastage, so on and so forth. And all these will go through, the IoT servers. I mean, your preventive analytical servers, as well as all your business processes, and the feedback into actionable items or actionable events back into the physical world. All right. Recently, I think it was sometime end of last year, I attended a virtual investor day by NVIDIA, because NVIDIA is one of the major players in IoT. So they have a very interesting concept. In fact, not just a concept, a project they call Earth 2.0. So basically what they do is, instead of having a virtual representation of a factory, they have a virtual representation of the entire Earth, right? Through, I think, their project called Omniverse. Right, so basically what they do is they take on all this environmental data, temperature, the sea level, the humidity, the wind speed, hurricanes, so on and so forth. They feed it into this Earth 2.0, which is a digital twin of the Earth. And then this Omniverse, they will actually generate this. I mean, they'll take this data and try to predict what may happen tomorrow or sometime in the future. They can use to predict hurricanes. They can use to predict other natural disasters like these tsunamis, so on and so forth. And the beautiful thing is, as every day, this omniverse of Earth 2.0, they take in all this new data from all the sensors and all these geostations around the world. They fit into the Earth 2.0, right? And then the system will recalculate, they will recalibrate the model so that the output of this model is going to be more accurate than the previous version. And this is how, this is the real concept of digital twins, right? And this loop will be ongoing, all right, so that you can always constantly improve the efficiency of the system. I think this is a very good, interesting concept. I believe that the implementation of digital twin is going to be much, much more than just manufacturing or, for geosciences, right? This is something that we can, I'm pretty excited to wait and see lah. Okay, now, next, I'm going to focus on this HPC, or what we call high performance computing. All these are related. Let me tell you why. Now, with this kind of system, right, what you need to have is a very strong computing power. Okay, now, as I mentioned earlier on, traditionally, because of the high capex requirement, a lot of companies opt to subscribe to cloud computing through services like AWS, Amazon Web Services, Microsoft Azure, so on and so forth, right? Where you, instead of owning the hardware on your premise, you can actually subscribe to a virtual server. Of course, there is a physical server sitting in a data farm or server farm somewhere, say in Cyberjaya or Singapore or whatnot, right? And you are just extracting the required computing power or space, to cater to your needs. Okay, so naturally, if you think about it, what is needed, whether it's on your premise or on the cloud or on data farm somewhere, right, is actually what we need a lot of supercomputers, computers that can process data, process operations much faster than our typical laptop or CPU, right? So that is the essence of that is the why we need high performance computing. So again, before I talk about the definition of HPC, let me just recap on where does it sit in the entire IoT stack. Now, this is a slide that I shared again in the last session, where we talk about where are the investment opportunities of industrial IoT. In the last session, we focused more on the sensors as well as the communication. That is where 5G and all these semiconductors related to sensors play a role. But for tonight, I'm going to move our focus towards the green boxes, which is edge network as well as infrastructure. And now the green here, as you can see, is that the role that they play in the IoT stack is the analytics. What are the hardware, what are the systems that is required to do your analysis, so that we can through this analysis we can improve the intelligence of the business process, or the efficiency of the productivity, so on and so forth. And tonight, we're going to focus on the edge network. Edge network is where your HPC sits, and where there's a lot of pre-processing of the data received from the sensors as well as from the communication channels, without going through into the cloud. And this is where a lot of computing actually happen these days. That is why early on when I started this session, I talk about the need, all right, to bring the computing power nearer to your premise, so that you can have more, you have faster feedback back into your system to improve, your efficiency, or to improve the mitigation or the feedback loop into the physical systems. Okay, I think part of the this is a report by Credit Suisse. It just highlighted, there are more and more demand for edge compute power as well as edge data centers. I think they did a great study. I think one of the key takeaways is that industrial IoT with use cases for remote monitoring and operations are in the rise. So a lot of these capex, all right, the market is expected to increase at least 4 to 5 times in not just Asia, in the Americas, as well as European countries, so on and so forth, right? They expect that the computing market, so the edge computing market, to grow by 18% compounding over the next decade. Right, from $670 million to more than 3.6 billion by 2030. As you can see here, the 4 key growth industries for industrial edge compute. I think the highest jump is actually in automotive. If you think about it, any manufacturing process that involves this high frequency productivity or that involves very complex processes will require will require more computing power, more computing accessibility as near as possible to the physical systems. And that is why automotive, I think industry will be the main driver for this edge compute market demand for the next 10 years, as well as semiconductor and electronics, F&B as well, and power. Okay, so this is from Credit Suisse. Now, coming back to what is edge actually? Edge is, I'm trying to simplify it as much as possible. What we know actually, what we are used to seeing with our eyes and what we're used to using is actually all these devices, which is part of the Internet of Things, right? So in the sense of industries or manufacturing, these IoT will be things like your humidity sensors, your temperature gauges, then your this water level sensors, okay, maybe your rotation sensors, so on and so forth, your power levels, all right? All these are sensors that will feed data into, of course, your compute power here. Now, the compute power can sit on either your edge network or your cloud. Now, what are the difference? The edge network is just simply saying a cluster of computers which sits near your physical systems here. So it can be in the same building, it can be in the same city, or as far as consumer is concerned, it can be sitting in your same house or maybe in your same office. This is where you can actually start to implement a lot of computing power, computing accessibility in your system already. Now, this is where you can do a lot of real-time data processing. You don't have to wait to the cloud. I'll explain why later. You can actually do real-time data processing at the source, and then you can feed back the output of this data processing back into your physical system so that you can improve or intervene certain processes to stop, maybe to prevent something from happening or to enhance the processes. All right, so this is where a lot of data operations are happening, including machine-to-machine communications, so on and so forth. Then, of course, there are some data which need not be real time. Maybe data that is related more to the back-end processes like business enhancement, right? Which can be actually, move on, which can be passed through to the cloud, where the cloud. The cloud network where you can store your data, there you can have more processes or more analytics can be done on a higher level. Okay, now most of the time the cloud servers will be hosted somewhere far away from the physical systems. I think in Malaysia, we do have a few cloud data farm or data server farms. I think one of them is in Cyberjaya, right? I remember last time when I was studying MMU, I always passed through this complex called NTT-Docomo. Just only recently realized that actually that NTT-Docomo is actually one of the largest data farms around the region. These days, I think other companies like this time.com, TM1, so on and so forth, are also building a lot of data centers around the region as well. Okay, so again, the edge network normally sits near the physical systems or premise, as we call it. Then the cloud will sit somewhere far away. Okay, now what are the 3 C's in the edge network? What are the key elements or the key roles that the edge network plays, and how we can bring this computing power nearer to the physical system through the edge, right? So in this website, I use a lot of resources from HPE, which is the Hewlett Packard Enterprise. They are one of the largest HPC supply in the world. In fact, they are the largest. Later, I'll show you the statistics. The three key elements is actually connectivity, control, and compute. Sorry, it should be connectivity, compute, and control. What I mean is, what this means? It means actually, these are the three key elements in order to make an edge network. First and foremost, you would, of course, naturally, you have to have the connectivity to transfer the data from the physical systems, the sensors, you know, so on and so forth, into your computing elements, your computing modules in the edge network. Then these servers, right, you process the data, all right, and feedback, you know, the analytics or the actionable, you know, the actionable events back to the system through a control loop. Again, going back to the connectivity channel back into your physical system, so that intervention can happen, right? To either prevent certain things from happen or to enhance the processes. So in the compute element, right? This is where what are the factors to consider is again, like I mentioned, latency. I think I mentioned about this in the last session, why latency is important. My next slide will talk a little bit more about this. Bandwidth as well, because obviously bandwidth is a cost to the business. Imagine if you need to run huge amount of data every hour, right? Huge, let's say gigabits of data every second or every hour, right? Then you need to have a very huge bandwidth to transfer this data. If let's say your servers are hosted somewhere far from your premises, that would be a cost. So it would be more efficient to bring this computing power nearer to your to your premise, so that you can save the cost for this bandwidth, which is related to cost here. Of course, by having your computing power nearer to your premise can, in a way, help you manage the threats, external threats from hackers and so on and so forth. But of course, that will depend on how strong is your security. Definitely, it's more reliable to have this compute power nearer to your premise. And last but not least, right, compliance also plays a role here. Now, certain industries, especially those that are regulated, like finance, especially in the banking, insurance, as well as other financial institutions, because of regulatory compliance, that they need to house certain of the processes or certain amount of the levels of data at a certain part of the, you know, I mean, in the premise or so on and so forth. So, for example, you know, in our line of work recently, we were looking at how to how to set up our own license fund management activities. Then we found out that actually we cannot host our servers, our computing power elsewhere. For example, if let's say we want to run our operations through another financial jurisdiction like Labuan or Singapore, right? We cannot say, hey, okay, I'm operating from here, my servers are there, then I can run the business. So strictly in the sense of compliance, some of this data, some of this computing power, or some the storage locations need to sit in the premise, or as close to the business operations. So compliance is also plays an important role when it comes to bringing these elements of your business closer to your premise, and this is where edge network plays a role. Okay, again, this is related to what I talk about. Because of this, a lot of computing power happens at the edge. Naturally, there needs to have, I mean, this edge network, this edge computing needs to be equipped with certain AI capabilities, so that it does not require the involvement of your compute power all the way from the cloud. Okay, now thin edge basically means the layer of the network where you house your networking equipment, like your routers, your switches, all right, just, I mean, before the cloud. Right, and then of course you can also how to say, implement certain compute power into this layer, so that you don't have to rely on the servers all the way back into the in the cloud farm. Okay. Now, this is the 4 stages of IoT architecture in the edge network. To really bring, to visualize how it looks like in from end to end, right? Again, this is from hpe.com. Basically, there are 4 stages. The first stage is, again, our physical world where our sensors and actuators are housed. Now, sensors is devices that take in the physical data, convert into electric signals and feed it into the IT world, right? Then in the IT world, the servers will process the data, analyze, and then feedback back to the system through actionable events. And this is where actuators play a role, because actuators in turn turn these electrical signals back to physical events, like, for example, increase the temperature, increase the speed of a rotary system, so on and so forth. Okay, so this is where your physical system sits. Now, of course, as I mentioned, this is the thin layer of your edge network, where there are internet gateways, your data acquisition system, your modules, your input output, all right, measurement systems, control systems are all housed here. Okay, then HIT is where your analytics and pre-processing happen. Now, of course, these 2 elements, these 2 stages can be housed on the same physical location, or they can be separated as well. But the interface between them is, I think technically they call this the edge. All right. Then, of course, after the HIT layer is where where you have your data center, your data farms, which is housed in the cloud. And this is more for business, high level business process management, analytics. All right, for archiving purposes, because you need to keep your backup somewhere for compliance or for other reasons, which I mentioned just now. But what I want to highlight here is actually on the bottom, the latency. Now, if you remember from my previous sessions on 5G, latency is basically the round trip time for the data to go through from the source to the internet back to the source again, like a round trip. Okay. Now, of course, imagine physically the longer the distance, then the latency will be much longer, right? Now, for example, typically between the physical sensors, the equipment, the physical equipment to the thin edge layer, which includes the internet gateways, your networking equipment, is normally less than 1 millisecond. Now, 1 millisecond is 1 over 100 times of a second. All right, so 1 second you divide by 100, right? So it's a very quick round trip, right? Just a blink of an eye. But as the physical connectivity reach longer, right, then you at the edge layer, we may require more hops of the nodes, right? Then we have a longer 20 to 40 milliseconds. Then, of course, further to the edge, it may be more than 1 second already. Okay. Now, certain processes, especially in manufacturing or telemedicine, or even autonomous driving in the future, right? We cannot have a latency of they cannot tolerate latency of more than maybe a couple of tens of milliseconds. For example, high-speed manufacturing will require very short latency. And this is where it becomes impossible or not logical, impractical for you to house your compute power all way over to the cloud. And this will increase the need of having your compute power nearer to your stage 1 of your IoT architecture. And this is why the edge network plays an important role. Now, just imagine, I think we were all very happy with our glove stocks, I think back in 2020, right? Now, if you remember, I think one of the latest glove manufacturing line can, I think, produce like 45 to 60,000 pieces of glove per hour. If you do your mathematics, right, that's equivalent to about one glass for every 10 milliseconds, or even the high-speed battery production lines, which is getting more and more popular these days because of the rising demand for EVs, right? Where EVs require a lot of these battery cells. And imagine if your system can produce say 100,000 battery cells per hour, right? Imagine per second how many cells are being produced. So all this data, all these processes which go through different modules or different parts of the production line, all these sensors will actually capture these processes and feedback to your IT, your servers, your compute power here, and then feedback. Now imagine if this were to pass to all, there is no edge that this processes this data were to be passed all the way to the data center and come back. That will be essentially about 200 milliseconds, all right? About 1/5 of a second. It may be too late for the system to intervene for in case that something's happened, right? And that is why latency plays an important role. I think in my last session, there is a slide where I summarize, where what are the processes or what are the applications in IoT that requires very, very low latency. I think they talk about smart manufacturing, smart city, smart grids, telemedicine, so on and so forth. Okay, so this is just to basically to highlight the importance of having your compute power nearer to the edge. But of course, this is where by compute power, what I mean is actually the need for having a HPC, your high performance computing power nearer to your premise as well. Okay, now let's move on next to this HPC. Again, sorry to Shane, I'm a bit behind time, so I try to be as fast as possible. All right. Now, HPC stands for high performance computing. It basically means the computing capability. Now, imagine most of us should have a laptop with us, right, to work or to study, right? So a typical laptop with a typical 3 GHz processor, right, in theory can perform about 3 billion calculations per second. That's why there's a giga, right? 3 billion. Now, 3 billion calculations per second may be a lot in our human capability, but in machining world, this is a very infant stage. It's very, very slow. Now, when there are a lot of applications out there which require much, much faster processing speed, all right, and that is where this HPC comes about. Now, HPC basically just means that a computer with the ability to process data and perform complex calculation at a much, much higher speed. In fact, where our typical laptop or desktop, which can do 3 billion calculations per second, a HPC can typically perform a quadrillion calculation operations per second. Now, what is a quadrillion? A quadrillion basically is a million gigahertz. All right, can you imagine the size of it? Now, of course, one of the best known HPC solution is what we call the supercomputer. The supercomputer is basically a collection of what we call a cluster of small computing layers, or what we call nodes, that work together to complete one task. Okay, now this highlights the basic definition of what is a HPC. Now, of course, HPC does not only involve the computing power, it also involves the connectivity, the networking element, as well as the storage system, or what we call the archiving. All right, so these three systems will actually make the entire HPC system. Now, another simplified HPC cluster diagram, again, this is from, I think, another source called Technical News, Dell. All right, so in terms of functionality or layers, the HPC will have a software layer, where is where your software is housed, your applications, like your workload manager, your containers, your orchestration. Basically means, the how the processes are being allocated through among the servers here. Of course, the servers are being powered not just by CPUs these days. Actually, because of the rise of the computing demand, actually more and more GPUs as well as other advanced technologies are being used to power up the servers. Then we have the storage layer as well to house your data for backups to be reused later on. Then last but not least is where your networking plays a role as well, where normally we use Ethernet with this direct memory access capabilities, because what HPC can do is HPC can be conditioned or designed in such a way that these resources can be shared among all these different nodes or these different servers. And these different servers can be physically, they can be in the same space or different premises. All right. Now, this is where there are two ways of implementing the HPC. One is on-premise, on your physical location, which can be in a building or in a campus or in a city or on a cloud, which is at a place far away from the physical system. Now, on the right-hand side is just a few pictures I gathered from the internet of how a typical HPC looks like. On the top, this is just a very simple rack system. I think this could be just a server station. All right, then you can also build a few of these racks side by side to form, let's say, a more powerful compute system here, maybe with more storage, storage space, or so on and so forth. Then these are where on the bottom is a typical picture of a server data center where you have a lot of supercomputers or even more of these racks that I talk about here. Now, of course, the cost will be different. In terms of category, HPC has 4 major categories: the work group, the departmental HPCs, the divisional, as well as the supercomputers. Now, of course, most of us should should have encountered a work group HPC. I think you can get this even from the net. Of course, some are not as much as $100,000. I think you can get a few. You can get, let's say, the Dell EMC, which is a kind of HPC for a fraction of the price. Now, of course, for higher demand, all right, work groups HPCs may not be able to give you the kind of compute power. So you may need to use a more powerful machine like the divisional or supercomputers. Now, for example, I think traditionally HPC applications are used for scientific research. I talk about the Earth 2.0, which is an Omniverse project by NVIDIA, where they have a virtual representation of the Earth as a digital twin. This for scientific research. Now, a lot of medical production and research also involves these supercomputers. Now, do you remember that back in 2020, when the COVID was blowing up, the pandemic was blowing out, right? Then you always hear, certain companies like Pfizer, they came out, with news or headlines about how they analyze the DNA of the virus and how they come out with, vaccines or other medications to tackle this virus, right? Now, all this require a huge computing power, and normally, they all will require the HPC compute power, right? Computer graphics are used mostly in, animation, your movies. You hear about the computer graphics, like if you have recently seen the Jurassic Park, none of the dinosaurs are real. They're all computer generated graphics or CGs, all right, which use HPC to render the images, to render the pictures, the moving pictures, so on and so forth. And of course, energy use a lot of HPC, aerospace, and other R&Ds as well. On the manufacturing arena, of course, HPC will play an important role in automation, all right, in predictive maintenance analytics, which I talked about just now, in machine learning to improve your processes, in computer-aided engineering, in AI implementation, so on and so forth. And this is where anything that requires a lot of computing power nearer to the premise of your physical system, you will need HPC on site. Okay. Right. So just now I talked about data centers. I think the report from this Credit Suisse, data centers are normally referred to the cloud. Now, this part here, we are referring more to the edge network on premise. All right. Of course, there is another angle to this, which is some businesses, some companies, they do not have the capability, the capex to actually invest in their own IT hardware. So they can subscribe to certain services like the AWS or the Google Cloud, all right, for the computing needs, all right. And this is where data centers play a role. As you can see here, this is the This is a recent research by DataBridge, right? We can see the explosion of the demand for hyperscale data. Hyperscale basically just means a huge, very high, huge scale of these supercomputers housed in a physical location. It can be co-location or other forms of accessing the computing power. And especially in Asia, where a lot of manufacturing hubs are being housed, right? Then demand for hyperscale data centers will be the growth will be even much higher compared to developed nations. Okay, so this is another angle to drive the demand for hyperscale data centers, which require HPCs. Now, and last but not least, again, a couple of forecasts by other market research like the Hyperion Research. Hyperion Research, I think, is a research company engaged by HPE to do all this market data research for them. So as you can see here, between 2020 to 2024, the compounding annual growth rate for HPC markets will grow about 8% per annum. But of course, not all verticals will enjoy the same growth. I think as you can see here, media entertainment actually having a huge growth here, as you can see here. Is where I talk about your computer generated graphics, your animations require all these HPC hardware, right? Manufacturing, energy, electronics, semiconductor, consumer products will also drive the demand, the growth for HPCs moving forward. And who are the major players, as I mentioned? Okay, the major players are basically these three brands. I think you all know. Most of our listeners should know. They command about 2/3 of the market for HPC hardware. And number one is Hewlett-Packard. They control about 1/3, followed by Dell, and then Lenovo. So three of them collectively own about 66 or 67%. And this is data as good as 2021. All right. So of course, are these the only three companies that we can invest in or we can look at for HPC? If you want to invest in HPC related themes, of course not. The entire IoT ecosystem is very huge, and tonight we only talk a little bit about the network edge here. In the previous session, we talked about sensors, we talked about semiconductors, right? There are a lot of other layers of players which comprises the entire ecosystem. In fact, if you can get your hand on this report by UBS on China 360, I think it is a recent report called IoT Diverse Technologies Three Shared Catalysts, right? You can actually see this. They actually outline who are the major players for each of these element of the IoT ecosystem. So tonight we only focus on the edge. Okay, so talk so long, right? Are there any investable companies in Malaysia, in Busan, Malaysia, specifically speaking, that can enjoy this apparently high growth HPC or edge networking booming demand in the next 5 to 10 years, right? Unfortunately, there is none but one company that so far we have uncovered. This company lately has been gaining a lot of interest among the social media like StockBit and as well as other bloggers as well. But before I bring this company about, right, let's talk about the company that truly enjoys this super growth of this rising demand of HPC, which is none other than TSMC. Now, if you read TSMC, Taiwan Semiconductor Manufacturing Company's latest earnings briefing, right, they highlighted actually the sales of smartphones are actually going down, and this is being taken over by high-performance computing sales. For the first time in the history, the HPC sales surpass smartphone, right? And then who are the major customers in HPC? All right, they are not the direct. They do not supply directly to HPE, Hewlett-Packard Enterprise, or Intel. Or Lisa just now, Dell, or even Lenovo, right? But they do supply the chips, the wafers and the semiconductor chips to the suppliers of those three names, including AMD, AMD recently just bought over Xilinx, NVIDIA, Broadcom, Marvell, Intel, so on and so forth. Now, among these players, NVIDIA, AMD, and Xilinx are very, very important players for HPC computing because they are they are the designers as well as the manufacturers of the chips, of the computing, the GPUs, the CPUs, the FPGAs, and so on and so forth, which is used to power the HPCs. Now, Broadcom also have their own compute solutions, but Broadcom also plays a role in the interconnectivity or the networking equipment for the HPCs. And remember, HPC is not just about compute power; it's also about networking. All right, it's also about storage, and storage is where memory plays a role as well. Okay, so I hope I get it clear. Intel is gaining a lot of traction in the HPC space. In fact, I think Intel is doing all the right business decisions by expanding the production across the world. So much so that they are slated to be the next major HPC customer for TSMC, because I think they have already given a lot of orders for the advanced nodes chips, the advanced node wafers to TSMC. Okay, so now, why is HPC so important and why is HPC so exciting as far as TSMC is concerned? Is because, as you can see here on the blue, if you just focus on the blue and the purple bar, the blue bar refers to the revenue of smartphones by application, and the purple is the HPC, right? You can see that very clearly, smartphone sales are very cyclical. They go up and down, depend on season, right? They are very prone to season cycles. But the HPC sales are actually quite stable. All right, you can see the HPC, the growth has been very stable on the uptrend since 2019. So much so that in the latest quarter, now HPC already surpassed the sales of smartphones. HPC contributed about 41%, while smartphones is 40%. Even with such a huge base, the HPC growth was actually 26% quarter on quarter for this TSMC. All right, you can see the huge growth. And I believe that moving forward, they are going to enjoy similar magnitude of growth, may not be as high as 26%. It should be at least a high double digits, maybe in the 10s or in the 20s. All right. And this is why, you can see here, the demand for HPCs is only going to go up because of all these the things that I talked about earlier, by more and more businesses, global organizations bringing the computing power nearer to the edge. Nearer to the premises or at the edge of the network. All right. Then, of course, TSMC, in order to expand their business, as well as for other geopolitical reasons, they are also building all this. They are constructing new plants around the world, not just in Taiwan. As we all know, Taiwan is in a very sensitive spot right now between the US and China because of political reasons. That's why TSMC also is very smart. They want to diversify their risk. They want to take care of the clients. So the clients in Asia, they say, hey, okay, other than Taiwan, although Taiwan is still my major hub, I'm going to build another manufacturing hub in Japan. I'm also going to build another hub in Singapore, because a lot of these semiconductor players also reside around Singapore as well as Malaysia. Then there is also, I think since last year or since 2 years ago, they also said that they want to build a plant in Phoenix, but I read that they hit a lot of snags these days because of resource constraint as well as cost issues, right? But what I'm trying to say here is actually TSMC is expanding the capacity around the world, and with that, of course, the suppliers will be happy, all right? And as I mentioned earlier just now, there is only one company that we uncovered listed in Bursa, Malaysia, that supply their services directly to TSMC, and it is none other than Frontken. All right, now Frontken has three major business segments. Of course, the major business segment is semiconductor. They also have oil and gas, especially in coating and rotating equipment, right? But the semiconductor is where bulk of the revenue comes from. Basically, what they do is they, foundries like TSMC, when their machines require a lot of servicing and maintenance, all right, maybe cleaning of the plates, the chambers, and then recoating with the required chemicals, right? And this is where these services can be outsourced to third parties like Frontken. Now, of course, Frontken is not the only supplier. There are a lot of local suppliers, especially in Taiwan, that competes with Frontken in this regard. But so this is a business of relationship as well as a race for technology supremacy, because if your customer is moving forward, is developing advanced technologies into the 7 nanometer, 5 nanometer, 3 nanometer nodes, right? You have to keep in pace. Otherwise, your current capabilities may not be able to cater for the demand. And that is why Frontken, I think in the annual report, the recent annual report, they claim that they started developing the advanced precision cleaning and coating processes for the 3 nanometer process technology in Taiwan, as well as in 8 nanometer technologies in Singapore. Obviously, this is to cater for the demand for the major client, which is TSMC. Now, what I found interesting about their logo, Frontken, I always wonder, why did they highlight F and E? Why specifically F and E? Then I came to think that F refers to foundries because major of the business come from foundries business, and E, it's just like the stacking of the wafers, right? Look like a few rows, right? So looks like an E lah. That is why the E is written in this way, right? Just a side note. Okay. Now, as I mentioned again earlier, semiconductor is a bulk of contributes a bulk of their sales, about 84%. TSMC is obviously the key client. The main thing about this business is that you need to be as close as possible to your client's premise in order to service them, because the equipment of these foundries are not small, they are not light, they are quite heavy. And they need a specific care, especially when you move them about, when you dismantle and reinstall them, right? So physically, they need to be as near as possible to their clients, all right? And that is why recently Frontken announced, that other than enhancing their capabilities for the more advanced nodes, they are also expanding their capacity in Taiwan, in Malaysia, in Singapore, as well as in Taiwan. Particularly of interest is actually their expansion in Taiwan. This is extracted from their annual report under the chairman's message. They said that I think in 2020 or 2021, they purchased an industrial building located in Southern Taiwan Science Park, which is in Kaohsiung. Now, Southern Taiwan Science Park, or in short STSC, is actually important science park. It's an important production hub for these semiconductor chips, as well as wafers, IC, so on and so forth in Taiwan. For the southern part, there are basically two parks. One is in Kaohsiung, one is in Tainan. So what I did was I extracted a Google map shown here. This is the STSP in Tainan. So this is the size is about 10 kilometers square in area. The red tags here refer to the location of the TSMC sites or plants. Right, as you can see here, there are a lot of TSMC plants housed in the STSP in Tainan. But this is not where the building that Frontken purchased. Frontken, obviously, I think for cost or for other reasons, they did not manage to find a building here. They found a building about 40 kilometers away from this science park, which is in science park, the STSP in Kaohsiung, in this place called Luzhu, all right, which is approximately 40 kilometers. I think relatively speaking, is like, PJ going to Kajang, that kind of distance. So it's not very far. It's not too near, but I think it's just nice for them to have a relationship with their major customer. So you can imagine, I think based on the AGM that they recently concluded, they expect this new plant to be ready for production towards the end of the year, which is in Q4. So imagine when that goes online, that kind of growth that Frontken is going to enjoy, right? So now, of course, on the quantitative or the financial performance, Frontken is also pretty pretty how to say strong in delivering a very good this financial performance over the past 10 years. As you can see, their revenue keeps on growing, all right, steadily, all right. And then not only that, all right, they have, interestingly, for this kind of business, they require very low capex, and that is why their free cash flow keeps on increasing every year, which in turn increase their cash position. All right, I think right now their cash is about 20 cents per share. The market cap is about 3.6 billion. Today is maybe a little bit higher because I understand today the share price was up about 3%. This was taken at the last day of April, which is 30th of June. At that time, the share price was about 229, which represents a 3.61 billion ringgit in market cap. Year to date, the share price has came down 43%. All right, so value is emerging definitely. Dividend yield is not that great; it's 1.7%, but at least they're still paying dividends. Apart from growing their business. All right, the net cash is about 19 cents or 20 cents per share, which translates to about almost 300 million ringgit. So that's about 10% of the market cap. Imagine 10% of the market cap is in cash, net cash. They're in net cash position, and the net margins is quite impressive, even for a business that just provides services to their customers, right? Their net margin is at impressive 23%. Their free cash flow margin is 10%. So, I know that a lot of us are feeling the pain from this recent market meltdown, especially on high growth sectors like tech. Now, if you're looking to, maybe keep an eye on some of the technology companies or semiconductor companies that, is worth your notice or worth your focus, right? When the market, eventually turns around, I think Frontken should be one of the candidates that you look at, especially if you believe the growth in edge network as well as HPC computing. So this is definitely one of the companies that should be in your radar. Okay, so other than that, of course, if you want to look for other companies to study, especially in the space of HPC growth, you can also look for companies listed in Malaysia that are investing into certain advanced packaging technologies, like this integrated fan out, all right, and all these other advanced packaging as well as chip stacking technologies that I talk about. Now, you'll be surprised that some of our local companies, especially the equipment players, have already invested or have already started looking into these advanced technologies. Now, I cannot name these companies because officially they have not announced anything yet. So a lot of them are based on our own guesses as well as all estimates. But I think if you are serious into wanting to look into the investment opportunities in HPC, if you grow for HPC, right, you should try to look for companies that are partaking in these technologies or investing in these technologies. So with that, I'm sorry, I overshoot my time, so it's almost 10 already. But maybe just give me one more minute for me to wrap things up. So I started talking about the rise of the industrial IoT as the next mega trend. I've already highlighted what are the driving forces, what are the transformation, the digital transformations that will drive the demand for this IoT, especially in the industrial segment, right? So as you can see, in order for this to happen, businesses or these manufacturers have to pull their compute power from the cloud, from somewhere far away, nearer to the premises, especially in the manufacturing outfits. And to do that, you need to invest in HPCs, all right? And one of the major players that we see that really enjoy the growing demand for HPC is TSMC. And in Busan, Malaysia, one of the companies that we uncovered that supplies their service directly to TSMC is none other than Frontken. So although there's only one case study, technically, so I hope you enjoyed my session tonight. It's a bit technical, but I have already tried my best to make it as simple as possible. So I hope you enjoyed the session tonight. Over to you, Shane.
thank you so much, David, for sharing with us HPC and also Industrial IoT. I think on Andrew say yes, of course. Thoroughly enjoy your session. So if you have any question for David, please, write in the Q&A box, not the chat box here. We probably take a few questions before we wrap up the session. Okay, we have to overshot for a little bit. So I know
sorry about
this is a bit more technical. Yeah, no problem. It's all right. I think I also started a little bit late due to technical glitch. So yes, question from Lim is that is Frontken the only company on Bursa serving TSMC?
Yes, unfortunately, that's right. I mean, that is why I highlighted directly, okay, directly serving TSMC. But I am sure that there are a lot of other semiconductor players listed on Bursa that serves customers or suppliers who are servicing TSMC as well. So maybe the second or third tier, I do not discount that. But for tonight, I only use Frontken as the case study because it's very obvious. They already highlighted in their annual report that TSMC is their key client.
Okay, thank you so much, David. The next question is by Y Lim. Normally, the life cycle for smartphone is 2 to 3 years as the software support expire. How about the lifespan of HPC?
Well,
likely to be longer.
Yeah, HPC actually the lifespan can be quite long depending on how you maintain, the systems. But then again, it's not really about the lifespan. It's really about your demand, your compute, as well as your networking demand. Now, as your business grow, naturally you require bigger compute power. You require more storage space. You require more advanced internet networking capabilities, right? So that is why a lot of companies they opt to implement the cloud option other than having the on-premise data centers, because on-premise HPCs can be very costly and you need to constantly upgrade your hardware. You need to, update your licenses every now and then, from your vendors and so on. And that is why many companies opt to subscribe to the the cloud version. So again, to answer Lim's question, it's not really about the lifespan of the hardware, but the demand for the business or the manufacturing outfit.
Okay, thank you so much, David. The next question by Seng Ho is TSMC listed on Bursa Malaysia?
Unfortunately, no. But we have a lot of other good semicon companies, especially the ATE players, the automated testing equipment, that I believe would be involved in the supply chain to TSMC, but maybe in the third, second, or fourth tier.
All right, thank you so much, David, for doing this segment for us. So let me proceed to share my screen here.
Again, very sorry for the time management. I really underestimated.
Yeah, it's all right. I think
I'll try to cut short on my stories next time.
I thoroughly enjoy your story revolving around the industrial IoT and also HPC. All right.
Thank you.
So yes, thank you so much, David. All right, so for our next webinar, it is titled Behavioral Finance, How You Stand in Your Way of Successful Investing. So it's happening on the 13th of July, 2022, which is the next Wednesday, 8:30 to 10 p.m. So I've given you the registration link. You may, register for this session if you want to learn about how do you manage your psychology in investing and what are the behavioral finance. Why we always, is our own enemy when it comes to investing. So in the next webinar, we will study in detail what are the psychology bias that we have and how can we stand out of our way in successful investing. All right. So please do join us in this session where we learn about behavioral finance. Okay. So thank you so much to David Poh, who is the founder of Spiral Thinker Group, who do this session for us, the Industrial IoT. So hope that all of you here learned a great deal as much as I do. So I'll see you on next Wednesday. Bye, everybody.
Thank you very much, Shane
Thanks,
and Bursa Malaysia. Good night, everyone. Take care.